this video, what we're going to discuss is the Kruskal-Wallis H test, which is a non-parametric alternative to the ANOVA. And an ANOVA is an analysis of variance where it compares the means of 3 or more samples. So because the Kruskal-Wallis H test is non-parametric, it's just an alternative to the ANOVA. So what we're going to do is we're going to write a program in Python to demonstrate the Kruskal-Wallis H test. And before we do that, we're going to have to import some libraries that we need to import in order to execute the program that we're going to write. So the first thing we want to do is we want to import NumPy as NP. And NumPy is a numeric library that also creates NumPy arrays. And then we're going to import pandas as PD, which is a data processing library, which also creates data frames and series. And then we're going to import matplotlib.pyplot as PLT, which is a visualization library. And from scipy.stats, we're going to import Kruskal. And so basically, scipy is Python's scientific library, and stats is the statistical module within scipy, and Kruskal is the test that we're going to be performing. So the first thing we need to do is we need to simulate data for 3 independent groups, and we're going to have to set the seed. The reason why you set the seed is so every time you run the program, the values will always initially be the same whenever you run it. So you set the seed by typing np.random.seed and anything you want within the bracket, or a number, any number you want within the brackets. So now what we're going to do is we're going to define group 1, group 2, and group 3. So group 1 equals np.random.normal. So that means you're going to create a normal distribution. Brackets 50, 5, 30. And so 50 is your mean, 5 is your standard deviation, and 30 is the sample size. And then in group 2, it's going to be np.random.normal, brackets 55, 50, 30. So your mean is 55, your standard deviation is 5, and your sample size is 30. And group 3 is np.random.normal, brackets 60, 5, 30. So your mean is 60, your standard deviation is 5, and your sample size is 30. So now we're going to perform the Kruskal-Wallis H test. Stat, p-value equals Kruskal, group 1, group 2, and group 3. And then after we've done that, we're going to print the Kruskal-Wallis H test statistic and the p-value. So your Kruskal-Wallis H test statistic is 43.274, and your p-value is 0. So if your p-value is 0, then that means the null hypothesis is going to be rejected because there's going to be a significant difference between the 3 samples. And you can see here on the box plots that have been made, there is a significant difference between 3 samples. So the median of the first one is less than 50. It's about 48 or 49. The median of the second one is 55, and the median of the third one is 60. So the medians and also the means, there's a significant difference between the medians and the means. So in this particular program, they don't ask you to check for the p-value, but if they did ask you to check for the p-value, the null hypothesis would be rejected because there's a significant difference between the 3 samples. So now what we're going to do is we're going to take the data and we're going to convert it into a data frame. So data equals PD dot data frame brackets, curly brackets, group 1 colon group 1 times len group 1 plus group 2 times len group 2 plus group 3 times len group 3, comma, value colon NP concatenate group 1, group 2, and group 3. And now we're going to visualize the data with a box plot. So plt.figure, fig size equals 6, 4, data equals box plot, brackets, by equals group, comma, column equals value, comma, grid equals false, comma, patch artist equals true, comma, box props equals dict, brackets, face color equals light blue, brackets. The title is Comparison of Group Distributions. There's not a subtitle. The X label is group, the Y label is value, and the grid is axis equals Y, comma, line style equals dash, comma, alpha equals 0.7. So you add the test result annotation, plt.text, brackets 2, comma, data, square brackets, value, comma, max, minus 5, comma, then it's p-value equals the p-value, comma, HA equals center, comma, font size equals 12, comma, color equals red. So you have a tight layout, and then you're going to show the box plot, which we've already seen. And now what you're going to do is you're going to create a histogram, plt.figure, brackets, fig size equals 6, 4, and then you're going to create 3 different histograms. So plt.hist, brackets, group 1, comma, bins equals 10, comma, alpha equals 0.7, comma, label equals group 1, comma, color equals blue, plt.hist, brackets, group 2, comma, bins equals 10, comma, alpha equals 0.7, comma, label equals 2, comma, color equals orange, and plt.hist, brackets, group 3, comma, bins equals 10, comma, alpha equals 0.7, comma, label equals group 3, comma, color equals 3, green. The title is Histogram of Group Distributions. X label is value, Y label is frequency. You get a legend. The grid is axis equals Y, comma, line style equals dash, comma, alpha equals 0.7, and then we're going to show it. So we've already seen the box plot because I showed you the box plot earlier, but this is a histogram of the group distributions, which group 1 is blue, group 2 is orange, group 3 is green. So you can see the mean of group 1 is 50, the mean of group 2 is 55, and the mean of group 3 is 60. So you can see that there is a significant difference between the 3 groups, even though you aren't asked to test the hypothesis test in this particular demonstration. It would fail the hypothesis test. The null hypothesis would be rejected in this instance. So that concludes this particular video. And the next video, we're going to talk about another non-parametric model. And so I hope you decide to watch it.